To GATE ECE channel. Today we'll be doing some problems on Z transform. I actually have an Instagram account as well as a Facebook page and a Facebook group where I will be uploading the questions related to GATE and also notes related to GATE ECE frequently. I am linking that in the description box down below. Please have a look at these accounts, and if you like the account, please follow it. Okay, without further ado, we'll start with the problems. The problems are given in the video itself. Please pause the video to write down the problem. So let's start with the x of n equal to half n square plus n into 1 by 3 n minus 1 u of n minus 1. This was given in the question x of n. The number of poles and zeros of x of z are respectively given by. We have to find out our x of z first. So I am just going to write the z transform of 1 by 3 raised to n u of n. So what is the 1 by 3 raised to n u of n? A raised to n u of n, its z transform is actually equal to z divided by z minus a, right, with ROC greater than a, right. So like that, 1 by 3 the whole raised to n u of n will have an z transform which is equal to z divided by z minus 1 by 3. Okay. Now, in the question it is given, I am just going to open this bracket and rearrange the term. We will get x of n equal to half n square, let a half be outside, okay, n square into 1 by 3 the whole raised to n minus 1 u of n minus 1 plus n into 1 by 3 the whole raised to n minus 1 u of n minus 1, right. So I am just going to take this part, okay, this part as g of n, for instance. So our g of n equal to 1 by 3 the whole raised to n minus 1 u of n minus 1. This will have an z transform of g of z, right. So this is actually a time shifted, that is shifted to the right side, right, shifted to the right side by 1. So whenever a time shift, we are going to use the time shifting property of z transform when time shifting, for example, the time shifting property of z transform is if x of n is having an z transform of x of z, and x of n minus 1 will be having an z transform of z raised to minus 1 x of z. Okay, these properties and proofs and all are given in my notes that are uploaded in my the Instagram account as well as the Facebook page. You can have a look at it if you want. So here 1 by 3 n minus 1 u of n minus 1 will have an z transform of this into z raised to minus 1, right, which is equal to z into z raised to minus 1 divided by z minus 1 by 3, which is equal to 1 divided by z minus 1 by 3. We can keep this aside. So now we will have, actually this is g of n, and g of n is multiplied by n, and we have to find out the z transform of n into g of n also, n into g of n. So here also we are going to use the property of z transform. So whenever if x of n is having an z transform of x of z and it is multiplied by x of n, multiplied by n, then it will have an z transform which is equal to minus z d by dz of x of z. This is a property of z transform. So here also, when n of g of n is given and the z transform of this particular thing is taken, it will be minus z d by dz of g of z. So it will be minus z into d by dz of 1 divided by z minus 1 by 3. So taking the z transform here, we will get z divided by z minus 1 by 3 the whole square. Okay. So for this we can write the z transform of that particular thing is, I'm just going to write like this, which is equal to z divided by z minus 1 by 3 the whole square. Okay, please you can keep it aside. And then the next one is n square into g of n, right. This is g of n only, that is multiplied by n square. So when it was n into g of n, it was like this, And if it is multiplied again by n, it will have an z transform. So let this z transform be f of z. Okay, then it will have an z transform of z into d by dz of f of z, right, which is equal to minus z into d by dz of this z divided by z minus 1 by 3 the whole square. We will do the differentiation. We will get 1 by 3 the whole square into 1 minus z divided by minus into z minus 1 by 3, right, divided by z minus 1 by 3 the whole raised to 4. So simplifying, we will get, just simplify it, z minus 1 by 3 the whole square minus 2z into z minus 1 by 3, which is equal to z into z plus 1 by 3 divided by z minus 1 by 3 the whole square. Okay, so this will lead to the z transform of this particular thing is z into z plus 1 by 3 divided by z minus 1 by 3 the whole cube. And now we will write it. So x of z will be equal to half into, the first one was z divided by z minus 1 by 3 the whole square plus z into z plus 1 by 3 divided by z minus 1 by 3 the whole cube. We will take the LCM here. We will get z into z minus 1 by 3 plus z into z plus 1 by 3. We will see what we will get. Right, which is equal to z square divided by z minus 1 by 3 the whole cube, right. So that is the answer. And now in the question it is asked how many zeros and how many poles are there, right. Number of poles and zeros of x of z is given by, so the numerator determines the number of zeros and the denominator determines the number of poles. So how many poles are there, how many zeros are there? 2 zeros and z minus 1 by the whole cube, right, and 3 poles. Okay, so option number D is the answer. Now let's do the next question, which is similar to the 16th question only, which is a continuation of the 16th question. So it will be appearing on the screen. Please pause the video. The output y of n of a system is related to its input x of n by y of n equal to, y of n is given, which is equal to sigma k is equal to minus infinity to infinity x of k, right. And let the input is given here, which is same as the previous input, that is x of n equal to half into n square plus n into 1 by 3 n minus 1 u of n minus 1. Okay. Now the steady state value of a y of n is given by, we have to find out the steady state value of a y of n. That is actually the steady state value is actually the final value. So we can use the final value theorem here. So for that we have first to find out y of z. Okay. So for that y of n equal to sigma k is equal to minus infinity to n. Actually it is up to n, okay, x of k. And what is y of n minus 1? Y of n minus 1 will be equal to minus infinity to n minus 1 x of k. Now I am going to subtract y of n minus y of n minus 1, which will give me x of n, right? So taking the z transform on this expression, we will get y of z minus z raised to minus 1 y of z equal to x of z. X of z we have already found out in the previous question. So y of z will be equal to okay, so y of z equal to x of z divided by 1 minus z raised to minus 1. So we'll get x of z, instead of x of z we are going to write z square, half into z square divided by z minus 1 by 3 the whole cube, the whole divided by 1 minus 1 by z. Okay, so we'll get z square divided by z minus 1 by 3 into we'll take the LCM over here, we'll get z divided by z minus 1, right, half into so this is our y of z, and now we have to find out our final value, that is the steady state value. According to final value theorem, in the z transform limit n tends to infinity, y of n will be equal to limit z tends to 1 z minus 1 into y of z. So substituting that here, we will get 1 by z tends to 1 by 2 into z minus 1 z cube divided by z minus 1 by 3 into z minus 1. Okay, this was cube, right? I'm sorry. One by 2 into 1 divided by 1 minus 1 by 3 the whole cube, which is equal to 1 by 2. 1 divided by 2 by 3 the whole cube, which is equal to 27 divided by 8. That is 27 divided by 60. That is the answer. Okay. So that's it. With that, I am going to end this video. We'll see you in the next video. Thank you for listening.